Good afternoon. This is problem number 1 from Module 8, the extra practice problems. The question states, nitric acid is manufactured with the following reaction. 3 moles of nitrogen dioxide plus water yields 2 moles of nitric acid plus 1 mole of nitric oxide. And the question asks, how many grams of nitrogen dioxide does it require to make, or is required to make, 2,945 kilograms of nitric acid, or HNO3. In this particular problem, you have to look, we want our answer in grams, but we're given our first value in kilograms. So we remember that for every 1 kilogram there are 1,000 grams, and we use this as our conversion factor in this part of the problem. So we multiply 2,945 kilograms times 1,000 grams, and in this case the kilograms will cancel, leaving 2,945,000 grams. However, we want 4 significant figures, and this number really should be written in scientific notation, and so we will write that as 2.945 times 10 to the 6 grams of nitric acid. Now, in order to relate nitric acid with nitrogen dioxide, we have to find out how many moles are contained in this sample of HNO3. And we do that by finding out another conversion factor, and to do that we have to find the molar mass of HNO3. To do that, we look at which atoms are present and how many. So we have 1 hydrogen, 1 nitrogen, and 3 oxygen. And we look at the periodic chart to find out the mass of just 1 atom of each of these elements. So for hydrogen, it's 1.01 AMU. For nitrogen, it's 14.0 AMU. And for 1 oxygen atom, it's 16.0 AMU. And then you simply multiply those by the number of atoms in your formula, and then add those together. So for HNO3, we have 63.01, but this, because we're adding, we round to the least precise number, and so we only want the answer to go out to the 10th position. So if we weigh out 63.0 grams of HNO3, that sample will contain exactly 1 mole of HNO3. And so we use this relationship to find out how many moles there are in our original sample. So we take our original sample that we have, the number that we were given, and we write that over 1. So we have 2.945 times 10 to the 6 grams of HNO3. And then we multiply that by the fraction of 1 mole of HNO3 over 63.0 grams of HNO3, so that these grams will cancel, leaving us with 0.046746 times 10 to the 6 moles of HNO3. However, we only want 4 significant figures, actually 3, because of this number here. Okay, and we want to write that in scientific notation. And so when we're rounding, right, we only want three digits. So we're going to go to this 7th position. So we look to the right, that number is a 4, so that 7 is going to remain a 7. And since we're making this number larger, we're going to multiply that by the power of 10. We have to go 2 powers less. So that number becomes 4.67 times 10 to the 4 moles of HNO3. Now that we know how many moles that we have in our original sample of HNO3, we look at the relationship or the ratio of the moles in our equation. So for every 2 moles of HNO3 that are produced, it requires 3 moles of nitrogen dioxide, or NO2. So this becomes our conversion factor. So for every 2 moles of HNO3 that are produced, it will equal or require 3 moles of NO2. So we take our original sample, right? We have 4.67 times 10 to the 4 moles of HNO3, and we multiply it by this fraction, 3 moles of NO2 over 2 moles of HNO3. The moles of HNO3 cancel, and we are left with 7.01 times 10 to the 4th moles of NO2. Okay, and that's great. So now we know how many moles we have or are required to make this 2,945 kilograms of HNO3. But if we look back at what we wrote down, we don't want the number of moles. We want to know how much grams, how much mass do we have to weigh out of the NO2. So again, we have to go back to our periodic chart and find the molar mass of NO2, and that is down here. In the molecule of NO2, we have 1 atom of nitrogen, 2 atoms of oxygen, and the mass on the periodic chart for nitrogen is 14.0 AMU, 1 oxygen atom is 16.0 AMU, and so we multiplied that oxygen 16.0 times 2, and then add those numbers together, and we find that 1 molecule of NO2 has a mass of 46.0 AMU. What this number does is tells us that if we were to weigh out a sample of NO2 in grams, so we can go over, take off the shelf a bottle, pour it out onto the balance, and we weigh 46.0 grams of NO2, that sample will contain exactly 1 mole of NO2. So we go back to that number we had just found, this 7.01 times 10 to the 4 moles of NO2, and we're going to multiply it by this fraction or this conversion factor to find out now how many grams of NO2 are in this sample. Okay, so we put 7.01 times 10 to the 4 moles of NO2, and this time we're going to multiply by 46.0 grams of NO2, and we place that number over 1 mole of NO2 so that those will cancel, and our answer will be in grams of NO2. And what I did, if you don't have a scientific calculator, you can do this just by multiplying the 7.01 and multiply it by the number 46.0. That will give you this number here, 322.46. And then you can't forget that you also have to then multiply that by 10 to the 4th. However, because of these numbers, we only want 3 significant figures, and we want to write it properly in scientific notation. So, in finding the significant figures, my 3 significant figures would be the 322, so I'm going to look to the number to the right, that's a 4, so that I am not going to round that up. So I want 3.22, and since I'm going to move that decimal number over 2 spaces to the left, making this number smaller, that means I have to multiply by 100 or 2 powers of 10, and so the final answer will be 3.22 times 10 to the 6 grams of nitrogen dioxide, and that is your answer for this particular problem. So what you find is that in order to make 2,945 kilograms of HNO3 or nitric acid, you will need to weigh out 3.22 times 10 to the 6 grams of nitrogen dioxide, which is what this was asking. And that is done.